Welcome to another video on SRID Cloud. In this video, we will talk about Ceph on Kubernetes. In a separate earlier video, I talked about how to install and work with Ceph storage on bare metal systems. But this one is going to be different, the same Ceph storage on Kubernetes nodes. So to do this, we're going to use Rook, which is an orchestrator for storage on Kubernetes. Ceph is not the only storage option for Rook. There are going to be some other, but in this video we'll focus only on Ceph. So let's get started. So what we're going to do is we are not going to install Ceph directly on bare metal systems, but this time we're going to prepare a Kubernetes environment. Refer to my earlier video on how to set up a multi-node Kubernetes environment. So then on the master node, you install what is called Rook, and that will take care of installing Ceph on the Kubernetes environment. So in the example that I have a Kubernetes cluster with 5 different nodes. One of them is a master node, and I have 4 other worker nodes. Out of the 4 worker nodes, 3 of them have additional storage attached to them. So the boot volume is obviously has to be there for the operating system to boot on these 3 worker nodes. And on top of it, I have a bare raw disks attached to them as well. So just like what we saw in Ceph on bare metal, here also these 3 additional storages will be combined together to form a cluster of shared storage for Ceph. And then we are going to be deploying pods on the same Kubernetes environment to consume the storage in the form of block storage or file storage or object storage. So how do we do this? We need to log into master node and clone the Rook repository from GitHub. And then it has got a bunch of YAML files, and we are going to install whatever that's needed for the Rook operator to function. So we will be creating what is called a common YAML, and then we'll be creating the operator YAML, and finally the cluster YAML. So the common YAML provides all the background information for the cluster for Rook and Ceph. The operator YAML will install the Rook operator that will act like a maintainer of a custom resource definition called Ceph storage. And then we are going to be installing the cluster, and that will enable the operator, the Rook operator, to create all the pods and all those things we're going to see later on. So once the cluster is created, then the environment is ready for consumption, and we're going to see how to consume the shared storage as well. So let's get on the practical aspect of this video. Here is my multi-node Kubernetes environment, and I would like to show you a few things before moving on to Rook and Ceph. So first of all, let's take a look at the nodes. So this cluster has 1 master and 4 worker nodes. The 1 monitor from Ceph perspective and 3 disks nodes, OSD 1, 2, and 3. When I initiated this Kubernetes cluster, I passed a specific value for the pod network. So let's take a look at it. So here it is, the KubeIDM init. The API server advertised address is obviously the local address of this master. And the pod network CIDR is set to 10.10.00.16. So this is important for operator to talk to the API server in Kubernetes. Otherwise, the Rook operator will not be able to produce the required parts, monitor parts and OSD parts and so on. So that is number one. And the second thing I wanted to show you is the Calico network that I installed. So I downloaded the YAML file for Calico, and let's take a look at it. And in this one, I uncommented these two lines for Calico IPv4 pool CIDR, and then set its value to 10.10.0.0, the same CIDR I entered for pod network during initializing this Kubernetes cluster. So these two are important. And then I did a kubectl create -f Calico YAML file to install the network on this one. So once again, let's take a look at the nodes. These are the nodes. So now on the OSD 1, 2, and 3, I attached additional storage. So let's take a look at that real quick. So let me SSH into SRI OSD 1. So here in this system, in this node Kubernetes, if we do lsblk, you can see the 10 gig disk I attached. That will act like part of the Ceph cluster later on. And I did it to all three OSD nodes. And this disk is empty. There's nothing on it. There's no file system attached to it. So it's empty, raw disk. So now let's proceed to download the Rook Ceph repository, and then proceed to installing the Rook operator and then Ceph cluster and so on. So I'm going to clone the Rook repository from GitHub, and I'm going to pick the latest version 1.3 here. So there it is. It is already cloned. And then I'm going to change directory to the Rook and cluster and example Kubernetes Ceph directory. And the first thing I'm going to do is apply or create the artifacts from common.yaml file. kubectl create -f common.yaml. So it has done quite a few things. The most importantly, it created this namespace Rook Ceph, and then added some additional artifacts. The second thing is to install the operator. So before that, let me make sure there are no parts in this namespace. In all namespaces, it has only the kube system parts, including the Calico and so on. And the etcd master is also, etcd pod is also running, along with the kube API server and so on. So now I'm going to install the operator, kubectl operator.yaml file. So this will set up the Rook operator. That is it. And let's see if the operator is up and running. Yeah, it just started to create the container. Let's wait for it to complete. We put it under watch. So it is also kicking off the discover parts on all 4 worker nodes. So these discover pods will discover both monitor and OSD on these nodes. So we should end up seeing one monitor pod and 3 OSD pods. So let's wait for those things to appear. While we are waiting, we can also take a look at the logs of the Ceph operator. So there it is. It is doing quite a lot of things, and it is trying to invoke the detection of monitor and also the OSD pods. Okay, I think the operator is in running state, so that's what I was looking for. Now the next step is to create the cluster. So for that we need to make some changes. So here is the cluster.yaml file. In our case, there is going to be only one monitor. So we have to make that change real quick. So the monitor count is going to be only one. That is the first change. And then there is something called data directory host path, the data dir host path. The var lib rook directory has to be there. So let me make sure I create that. Okay, I created the rook directory under var lib. So now I'm ready to create the cluster. Okay, the cluster, the subcluster is created now. So now let's look at the kubectl get Ceph cluster -rook Ceph. There it is. The cluster creation is in progress. And let's also do watch on kubectl get pods. Let's do only rook Ceph. So you can see quite a lot of things are going on. The OSD pods are getting created. The monitor is also got created. I think everything is done. So most importantly, the Rook Ceph Manager pod is up and running, and then the Rook Ceph Monitor pod is also up and running. It's running only on only one, because we have only one monitor, and we have 3 OSD pods up and running because we have 3 OSD nodes. Let me run this with wide format. It's such a huge output to see the node on which it is running. For example, the Ceph Manager, the last entry here is running on the second OSD and drive. So let's do this again. Make sure all pods are in running state. They're all running. So this has successfully installed the Ceph on this Kubernetes environment. Now the next step is to figure out how to consume the storage provided by Ceph made possible by Rook. We will end up creating a storage class and then a persistent volume claim, and then that should create a persistent volume, and then we're going to create a pod to see if the volume can be consumed. So let's do that. So to verify quite a few things, we need to install what is called Rook Toolbox. So let's see how to do that. I'm going to create a new artifact. It is already defined in toolbox.yaml. So this toolbox will help us to see if everything is okay. And I'm going to run this toolbox now. kubectl create -f toolbox YAML. Okay, got created. Let me see kubectl get parts, all name spaces, and we need to look for the toolbox. So there it is, the Rook Ceph tools. So now we are going to log into this toolbox pod and run some Ceph commands. So this will help to see if the toolbox got created successfully. There it is. And then I'm going to run this one. I'm going to log into this pod and also run the bash command. We put it in the middle. There it is. So I am inside this toolbox pod. So let me run Ceph status. So everything is fine. There's one monitor. The quorum is set to A. I think they recommend 3 monitors for better quorum. And then there are 3 OSDs as expected. They're all up and running. And there are no pools defined yet. And out of the 30 gig, because the OSD 1, 2, and 3 were attached with 10 gig each. So the total, there is a 30 gig space is available in this Ceph cluster, out of which 3 is already used by the management. The 27 gig is available for persistent volume claims. Let us run some other commands. Ceph OSD status. So these are the 3 disks, 3 nodes actually in the Ceph cluster. And let us run other commands like Ceph df, how much disk is available and all that. And finally, so let me run some other commands like Ceph df. Will give me an idea of the disk characteristics, and also the block device rados df will also give me an idea of how much space is available. So these are the utilities that you can run to look at the status and other characteristics. And if I want, I can delete this Ceph tool pod with this command. I'm not going to do that, but I'll show you. This is the command that you need to run in case if you do not want this Ceph toolbox VM to be hanging around. But I'm not going to delete. I'm going to keep it for now. So now the next step is to get on this storage class and persistent volume claim and persistent volume and so on. Before that, we need to create a pool as well. So let's get all those things started. So let's create a pool in this Ceph cluster. So there's a file called pool test.yaml, the same directory that we have all other YAML files. and let me create that now. kubectl create -f pool test.yaml, and the replica pool is created. Let's make sure nothing got impacted. So everything is looking good. So now let us get on this toolbox and see if we can locate the pool that we just created. So we are inside the toolbox, and let's show Ceph status. So there it is, one pool is available. And let me run commands like Ceph OSD. Hold on, I think I need to find an exact command. So Ceph OSD status. And Ceph df. There it is. So replica pool is the name of the pool that I just created, and maximum availability is 25 gig. Now inside this Ceph toolbox, I'm going to list all the pools. We can do that with this command as well. OSD ls pools. There's only one pool, and I'm going to create an image that I'm going to push it into this pool. So to do that, I need to use the rbd command, create my image of size, say 10 gigabytes, I think, and then -p replica pool. So it got created. So now let's see if the creation went through successfully. So rbd info my image -p replica pool. So there it is. So it was 10 megabytes, not 10 gigabytes. So everything is okay. Hope you enjoyed this video. In this video, we talked about how to set up the Rook operator-based Ceph storage in our Kubernetes environment. So now in separate videos, I'm going to talk about how to consume this Ceph storage. First of all, we're going to be doing a block storage, and then we're going to continue on to object storage, and then finally a file storage. So I think that will give you an idea on not only how to set up Ceph on Kubernetes using Rook, but also how to consume them in the form of applications like pods and other artifacts in Kubernetes. So wait for those videos, and have a wonderful day, and I will talk to you all in another separate video. Bye for now.